Good morning all. This gadget just turned up and I'm intrigued to know what it is. It's got several parts, cable, and this bit, oh, a cable just fell out. So this is what we've got, a control box here. Now it says Ming, so this is by the Ming company. Up, down buttons and OK, and presumably a colour LCD. And I've got a feeling this is wireless, so this unit here talks to this unit here, which has a monster 30 amp relay on it, wirelessly. This also has a USB. Now it's not what you're probably thinking. It's not a DC to DC converter. What I think this is, what I'm pretty sure it is a voltmeter, an ammeter, a wattmeter, and also has over power, over volt, over current probably protections. And I think that's why the relay's there, so that it's monitoring voltage, current and power. If you go over one of those settings, the relay will cut out. Wireless connection, I believe, between the control unit and this. I'm not sure what the wireless is, what frequency it is, or what type of communication it is. But yeah, interesting. I'll have a little read of the manual and then I'll start wiring it all up. Well, that's one question answered. The wireless is using an NRF 24L01 Plus board there. There's an ST microcontroller there, crystal, regulator, little power supply there. Not sure if that's buck or boost. Now this is interesting. You've got a sort of USB, well, I'm not sure whether it's male or female, soldered onto a sort of dual header there. So I think the idea is you use this extension lead, plug the female onto there, and then you can power this from a power bank, I guess. So I'm going to go and get a power bank, power this up and see what happens. Now it seems that you can power this either with USB 5 volts, or you can use this very short length of wire connected to this 2-pin JST, plug it into there and put anything from 10 to 30 volts on there, regulated down presumably by that regulator. And when you do power this thing up, you get this. Quite a lot of stuff on the display there. Volts, amps and watts. We've got a section called dis, I'm not sure what dis is, discharge maybe. That shows amp hours, watt hours, and that looks like time, although I'm not quite sure what that first pair of zeros is. And loads of little 3-letter mnemonics here: NCP, OCP, LVP, low voltage protection, overcurrent protection, something current protection, over voltage protection, out, clear, bat, set, and ADR. Address is that? Now I've no idea what I'm doing with this, but I'm just going to press OK. That didn't seem to do anything. So a bit more of manual reading, and then I'll start taking a look at this unit. This appears to have 4 screws in it, so they'll be coming out, and we'll take a look inside there. Right, I've taken the bottom off this thing, and this board is now loose, but I'm not going to be able to remove it. You can see the NRF 24L01 Plus module there. It's probably a microcontroller sitting on this board. I'm not going to be able to take this right off unless I take these JSTs out, so no. Well, that was easy. So yeah, there it is. Let's get in a bit closer. Right, that NRF module appears to be in a socket, so let's take that out. And we can see under there the microcontroller. That's an ST microcontroller, I think. Yeah, I'm pretty sure it is. 16 megahertz crystal. A few other bits and bobs. There's a switch mode control chip up there. That's an XL1609 and an inductor there. So we're either stepping up or stepping down there. I just wonder actually whether if you put a voltage across the input here, whether there's something in here which can tap off that, regulate it, and supply power to the electronics here. There is on this unit a separate external DC power supply. From my reading the manual, it says something about powering the relay, so I'm not quite sure whether that's needed all the time. But yeah, it'd be interesting to find out. I suppose I better put this wireless transceiver module back in there and put something on these input and output connectors. Right, so I've put a bulb on as my load. It appears to say in the manual, although the manual's a bit unfathomable, that you can actually pass current the other way. So if you've got a battery here, for example, you can charge it and discharge it and see the current in both directions. I believe that's what it says. Right, I've got 12 volts here from my solar system. Actually, it's about 13. So I'm going to plug that in. And nothing seems to have happened. So is it the case that it can't tap off this this main supply to power the unit? It could be that. I suppose this could be up to quite high voltages, so maybe it doesn't do that. So maybe I need to put 12 volts on there. You have to have a lot of power supplies for this. Also, I noticed there's a USB out here. I wonder if that just takes the 12 volts going in there, produces 5 out, and you could use it to power the wireless remote module. I don't know. I think I'll just swap that connector over onto these terminals for the moment, put 12 volts on there, and just see if we get communication between the two units. Let's do that. So it says, note this instrument is equipped with a 12 volt relay. An external power supply must be 12 volts or cannot drive. I mean, 12 volts, is there any tolerance on that? When customers use upper wiring current, oh, I don't know. But anyway, let's put 13 volts on there and see what happens. Right, here goes. We have a click. The relay's pulled in. We have a red LED. And we've actually got a small voltage, 0.05 volts on there. So I think what's happened is the transmitter has powered up. It's now sending data to the receiver. It's measuring a small voltage across the input or across the output. Can't be sure yet. So there's a slight voltage error there. But I'm also going to need a power supply to power this bulb. Now I wonder whether I can simply run a wire from this 12 volts out and into there. It depends how the grounds are connected. If the two grounds are connected together, I could do some continuity tests. Then I may be just able to borrow some 12 volts and put it in as my source for the light bulb. Yeah, let's take another look at this circuit board. Try to get this top PCB off, but these are so tight, these screws. I think I need a bigger screwdriver. Right, that's got that off. So let's lift this top board off and just see how the wiring is between these two connectors. Well, there's some pretty big wires or tracks underneath here. So we got in positive to the relay, out relay must be there. So that goes to out positive. In negative goes through this huge link. So that's the current sense resistor, I'm guessing, straight to out negative. So the question is, where are positive and negative on this power supply connector connected through to this high current stuff? Right, because I can't quite see the wiring on this, I'll have to at some point do a schematic of it. But for the moment, what I've done is I've put this power bank onto 12 volts. This is the multi-voltage output one. Brilliant power bank this is. To power this unit, separate power bank 5 volts for the control panel, and now my solar 12 volts will go in as an input. Just make sure that's the right polarity, and that powers up that bulb. That's actually a 24 volt bulb, so it's going to look quite dim. And now we've got some useful data on the receiving unit, so let's have a look at that. So on this little control panel, I'm currently set to the out mode. There's a thing saying on. That symbol top left is now showing that it's receiving data. That was a red X before. I can probably show that by depowering that, but I'll do that in a minute. Now it looks like in the out mode, pressing the OK button switches this relay unit off, and pressing it again switches it on, so that's quite fun. Right, I'm now in the clear mode. There's actually a peel thing here, so I'm just going to peel that off. It's counting up amp hours and watt hours, and actually this battery state of charge thing is gradually coming down. So presumably you put in battery details, which we'll look at in a moment, and it can give you a rough indication of how much energy has come out of the battery and how much has gone in. And this will give you an indication of its state of charge. But if I press OK on clear, it resets all these parameters. So the watt hours went back to 0, amp hours went back to 0, and the battery state of charge went back to full. Did it clear that timer? I think it did. Yes, it did. It cleared the timer. Okay, next let's come down to battery. If we go into there, now we can set the battery range 0 to 6500 amp hours. My batteries outside are probably quite a lot. That's set to 0 amp hours, so let's put something in there. Press and hold, yeah, that works. I don't know, 6 amp hours. That seems reasonable. Okay, what else can we do? Amp hours setup, range 0 to 100%. Well, that seems sensible. What options are there? Not quite sure what that means, but you can set it in increments of 10%. What else have we got? Okay, that's all for the battery setup. Right, this one, ADR, address, that appears to be the address of the NRF module, so that that's A01. If I put that up to A02, we get the red X showing that we're no longer receiving wireless data. So presumably there's an address set up also on there. Or, I suppose, yeah, there must be, but it does mean that you could have multiples of this unit and use one of these for monitoring several of those. I'm not sure whether you can buy these independently, but it looks to me that's what you can do. So we'll set that back to address 1, and that wireless receiving indicator comes back on. What have we got? We've got 12.82 volts. Actually, if I go back to out and turn it off, then that voltage shoots up because of course there's some loading on this input cable. Turn that back on. 9 watts are being consumed by this. This is a 24 volt 21 watt bulb, so at 12 volts of course it's going to be about half of 21 watts, so 9 watts, 0.7 amps, 12.97 volts, and all this cumulative data as well. That's quite good. So what have we got? Over voltage protection, low voltage protection. Now I'm guessing that will protect against, say we have a battery on here, we can get the relay to cut out when we get down to a certain voltage. Let's try that low voltage protection. 0 to 120 volts. Yes, this unit is actually capable of taking up to 120 volts and up to 30 amps. You can see that that current sense resistor is absolutely enormous. So let's say that we want a low voltage protection at, what would it be? Well, this went down to about 12, let's say 13 volts. We're just above that. 12.8. Okay, let's try that. Now, how do I make it do that? I'd probably have to go outside and cover the solar panel, so maybe that's not the best thing to do. Right, I've set the output to off. I've set the low voltage protection to 13.2. The battery is currently higher than that. So if I come out of low voltage protection, the bulb turns on. Now if that voltage drops below 13.2, which it did, then the relay cuts out and my low voltage protection has worked. Let's go down to out, switch it on, and it switches off again because it drops below my low voltage protection. There's a little indicator there as well, LVP. So that shows why the relay cut out. That's really cool. Right, we're drawing 0.7 amps, so let's set an overcurrent protection of about that's quite a, That's interesting. That just rebooted. Is that something to do with my 5 volts? Where was I? Over current protection. And I want, well, 0.7 amps, I guess. That's about the nearest I can get. Let's set that. So yes, the over current protection has kicked in. Let's go back to out. Switch on, and the over current protection immediately protects the thing, and we've got an OCP. Now there is an NCP, which is a negative over current protection, and I think you can set that separately from the over current protection to protect against current flowing the other way in installations where you're charging a battery, for example, and discharging it. So we'll just take a quick look at that. And in the negative overcurrent protection, we can set a value between 0 and minus 30 amps. In the overcurrent protection, we can set a value between 0 and plus 30 amps, so the ranges are the same. Now I think we have a bit of a dodgy USB extender cable, because I was waggling it about a minute ago and it just cut out. So it might be worth getting another one of these. It won't do it now. It seems absolutely fine now. Right, a couple of other things. If you press and hold on and then let go, the little lock symbol goes red. Press and hold it again and the little lock symbol goes green and unlocked. So that's a key lockout device. If you switch the output off, you'll see this clock, which is on 640 something. The clock actually stops. All the cumulative indicators hold their data, but they sort of freeze. If I switch the output back on, the clock restarts again. Now, what about range? I mean, with this unit right next to the measurement unit, of course I can control that very easily, but I just tried taking this module outside and I really didn't actually get outside. I just got to the back door and the receiver symbol went to an X. So the range doesn't seem that impressive. Now I'm not sure whether that's because the transceiver is sitting right next to a microcontroller and it's interfering with the transmission, but there doesn't seem to be a lot of range. I'll see how far I can get with this unit. Now, as I say, I was going to take this outside, but just as I decided to do that, it starts pouring with rain, so that's not going to happen. So it's sat here next to the back door, and it's a bit intermittent. It's sort of going between getting a signal and not getting a signal, and that's not really very far at all. That's about 10 meters away through a couple of walls. It's not very impressive at all, really. Let's try switching the output off. That seems to be off. Let's try switching it on. Yeah, I heard the relay click and that's gone on, but we're not getting any data returned. Now I am getting data, 12.6 volts, 0.7 amps. But yeah, that range is not very impressive. So certainly I'm not going to be able to put this measuring unit on the battery that's halfway down my garden. It simply doesn't have the range for that. I could possibly put this measurement unit on my battery bank, which is just outside the window that's just in front of my desk here. The range, I'm sure, would go through one window and about 2 meters of distance. But yeah, I was rather hoping I could put this out in the garden and monitor it from inside, but don't think that's going to work. So let's have a look at this device on eBay. It's a DC battery wireless 120 volt 30 amp LCD, yeah, color LCD, voltage, current, watt, power, capacity combo meter. Wireless, of course. We know now that it's an NRF 24L01 plus. Now this was $22.92, free shipping, and I got this one from Alice Happy 858. Okay, so the information in the description section is possibly a little better than the manual, but it's written by the same person, so we got the same style of English. But there's some explanation of what all these things do. lots of well, steps for hooking it all up. Now some spec here, 0.01 to 120 volts, accuracy is 0.01 volts, error 1% plus or minus 5 figures, current is 0.01 amps to 30 amps in what's that, 100 or 10 milliamp steps, I think that is, and that's plus or minus 2% plus 5 figures. Power measurement range 0 to 200 kilowatts. That's presumably these two numbers multiplied together. Actually, it isn't quite, is it? But anyway, 200 kilowatts. Is that correct? Capacity measurement 0 to 2000 kiloamp hours. I don't think that's right. Is that right? Watts 0 to 4000 kilowatt hours. I'm not sure that kilowatt is correct. Time up to 999 days. We've got the address ranges. There are 99 different addresses you can use. Wireless channel setting range A to Z. Oh, I didn't see that. And then all these negative, or these over protections, overcurrent, negative overcurrent, positive overcurrent, over voltage, and under voltage. There are some dimensions here, weights. We've also got the different ways you can power the meter, the monitoring unit, either USB or 10 to 30 volts on this pair of wires on that little JST connector. How to wire up your external power and load, but it doesn't say anything about whether you can tap off that to actually power the module. Doesn't mention that. There's a bit here about facilitating this unit on electric cars. Now I'm not sure whether 120 volts 30 amps is going to be quite enough for an electric car, but I think really what it's saying is that you can monitor charge coming into the battery and also then going back out to the motor, and that's about it. One other thing I've noticed is that if you power this module on with power coming through, this happens. It briefly flicks on and then goes off. Now I'm not sure whether you can change the default status to off. Oh, actually that might have happened because of the low voltage protection. Let me just try that again. Yeah, the behavior is now different. If I power it off, it goes off obviously, because the relay drops out. There's no power to pull that in. If I power it on, that comes on. Now what if I change the status to, on the out thing, to off? Will it power up in the off state? No, that powers up in the on state. That's rather strange. That's saying on. So I'm not sure whether you can get this thing to power up in the off state. I'll play around with it for a bit. Aha, what's this? Under set, I've got start status. Range is on or off, so that's currently on. Let's change that to off and OK it. Delay time. Oh, that's fabulous. Okay, let's do 2 seconds. What else we got? Relay level. Range high and low. Don't know what that is. Display off time. Okay, you can have the display go off after so many seconds. I don't really want that. Okay, so that's gone off. Let's go switch that on, switch that back off, and now presumably if I power this on, hopefully without a glitch, yeah, that doesn't come on. So yes, it does seem that there is a setting in here to decide whether this powers on automatically when it receives power or whether it stays in the off state. I like that. That's rather good. So there it is. It's a voltmeter, ammeter, wattmeter with cumulative data. A very nice color display. It's got all sorts of protection facilities. That's protected by a relay on the switching. That relay is rated 30 amps. It's wireless. The wireless range isn't fantastic, but you've probably got about somewhere between 5 and 10 meters of distance, possibly more if you're line of sight and no obstructions. Yeah, I think it could be a very useful unit. Quite course, you can get watt meters with the 2x16 LCDs for under $10. I've got one coming actually. This is $22, but if you want these extra functions over and above those very simple watt meters, then maybe this unit would be for you. Anyway, I think I've done all the testing I can do on this, so that's it. Cheerio!